I'm going to do another Newton's law, or another physics theater exercise. And this is one to illustrate another point about force, which is real important. And this is one you're already familiar with at some level. And this one is actually theatrical. I want you to come down, and I'm asking the people who are taking part in this one to act for us. You're going to make us believe something, OK? You're going to make us believe something. So I'm going to call 6 names out of the box. We are going to play a make-believe game of catch. OK, we're going to play like catch with a make-believe ball. So I want you folks to stand in a circle. Go ahead and stand in a circle. And what I'm going to do is I'm going to give you like this imaginary ball. And then you're going to like toss this ball back and forth. And I'm going to tell you, either the ball is really heavy or the ball is really light. And you folks are going to toss it back and forth. And you folks have to decide heavy or light. And so we're going to be thinking like, how do you let them know it's heavy or light? And then how do you figure out that it's heavy or light? OK? So I'm going to give you the ball. It's really light. Sorry, you probably heard that on the microphone. That kind of screwed that up, didn't it? OK. Boy, I'm going to try that again. OK, set it down, don't hurt yourself, and be careful. OK, now we're going to do it again, and this time, watch out, it's going to hit somebody. You can just toss it back to me. I'll set that one on the podium. Thank you. And I'm just going to put it right over here. OK, let's have a hand for theater participants. OK, which one was the heavy one? The first one. And you know that. And actually, I only told one person. And she communicated the idea that it was heavy to everybody else. How did she communicate that? A lot of effort into it. Oh, sweet. That's exactly the word I'm looking for. This is our first law of physics. This is a big moment. This is the first thing I've actually taught you this semester. Okay? And this is going to encapsulate a lot of the things that we've been talking about. Newton's second law, we write it this way. Acceleration is equal to force divided by mass. When you're playing catch, you're tossing a ball back and forth. You're changing its motion. Oh, because initially it's just sitting there, and you need to make it go someplace. If you're changing its velocity, that's an acceleration. An acceleration requires a force. That's the law of physics we want to look at right here. If I want to have an acceleration, I have to have a force. Now, if you're playing catch, you're going to have a certain acceleration. If I have a big mass, what does that tell me about the necessary force? Big force. And that's how you knew it was heavy. It took a lot of effort. You had to like put a lot of force behind that thing to get its velocity to change. On the other hand, the lightweight one didn't particularly take a lot of force. Okay? And so you can telegraph that, and you know this in your heart, that if you want to make something move, if it's big, you have to push harder. And so this is something at some level you already know. You also know this, too. If you're going to make an acceleration and make a change in velocity, it requires a force. If you're going to start your car or you're going to stop your car, you have to have some sort of a force in order to make that happen. And we'll talk more about specifically where that comes from. But you know this. You know this already. I'm going to do one more thing here. And this is a little magic trick. And this is like a classic magic trick. And it uses this idea right here. I'm going to go ahead and put down a cloth on the edge of this table. I'm going to put dishes out on the cloth, like so. So cloth goes down, dishes go out. You know where this is going. Oh, yes. Oh, yes. And then what I'm going to do is I'm going to like yank the tablecloth out from under the dishes. Okay? And that's this problem right here. The dishes are currently at rest. I'd like them to stay at rest. Okay? Now, if I pull this cloth to the side really hard, okay, that's going to be making a force that goes in this way on the dishes. What is producing that force? What kind of force is this? Friction. There's a frictional force from the tablecloth, okay? Now, the thing that I care about is I don't want these dishes to go flying off the table. So there's two things I can do. One is I can use a really slippery piece of cloth. And if I use a really slippery piece of cloth, the frictional force is low. The other thing I can do is I can minimize time, because it's true that the change in velocity is equal to the acceleration times the time interval. And I'm going to have a friction force. There's nothing I can do about it. I'm stuck with that. I can make it small, but I'm stuck with it. If I have a force, I have an acceleration. The only way I can minimize motion is by having the time be real short. So slippery cloth, short time. And the key to this one is just short time. You will have friction. You just have to keep it from acting for very long. And so the key is the snap. If you do this high, and you get yourself a fair amount of slack like this, and then you pull down real hard. You want to be able to get your hands moving, pull down really, really hard. And you go 1, 2, 3. And it's out from underneath. Works pretty well. Now, to prove this is not a trick, this is a physics thing. Let's see. Who do we have here? These are the first dishes that my mother got my wife and me. I'm serious. So these have like tremendous emotional resonance with me.
Okay.
Okay. And that's how much I trust you. I just want you to know that. Okay? So put those there and put some dishes. And the key is you don't want to go up. Going up like puts the dishes everywhere. But if you go just down, so grab it right about here, pull it up, and then snap down, and snap down hard. Okay, ready? And whenever you're ready. Sweet! That was better than me. That was well done. And it's not, so this isn't a trick. This isn't a trick. This is just physics in action. And it's surprising, isn't it? And the key is small force, short time, and don't launch the dishes. Don't go, whee! Don't go up. That's bad. Going down is a crucial thing.